Hi, good afternoon, everyone. Welcome back to our YouTube channel. So today we are going to learn about a part in electric vehicle, which is nothing but conventional vehicle. So already you know what is meant by conventional vehicle. The vehicles which run with petrol and diesel are called as conventional vehicles. Okay. So to this conventional vehicle, what are the vehicle power source or vehicle power source characteristics? Okay, this is very important. So very important when you are performing your academic exams. So coming to the vehicle power source characteristics, here we are going to derive the expressions for the torque generated at the wheels of an IC engine, as well as the traction force generated at the wheels of an electric vehicle, as well as we are going to get the speed at the electric vehicle, and we are going to calculate the velocity of the electric vehicle in terms of meter per second. So now we need to get the empirical formulas for all these four parameters: the torque, force, speed, as well as velocity at the wheels of an electric vehicle. So coming to the diagram, so here you see, here we don't have any derivation for this. So actually we have only empirical relations for each individual formula. Let's try to understand it. So here you can understand it from the dynamics. So clearly you can have a complete derivation from the dynamics of an electric vehicle. Okay, so dynamics of an IC engine as well as the dynamics of an electric vehicle. Let's try to see the diagram and how it represents. Okay, so coming to the concept, so we need to find out all these four parameters. So first one, let's try to assume that in an IC engine we are going to have an engine here. So this is nothing but the engine what we have, and this engine is connected to the transmission. So this is nothing but transmission. We generally call it as a gearbox. So this is called as transmission, and from this transmission we are going to, so this, which is nothing but, which is called as a clutch. So using this clutch, this transmission, we call it as gearbox. So by using this, engine will be connected to the gearbox with the help of clutch mechanism. Okay. So this clutch is like manual transmission, which is used to couple or decouple. So if we want to couple or decouple the gearbox, this clutch is very useful, and output of this we are going to get a small differential. Okay, so this is called as differential. What is the purpose of this differential, or the one more name of this differential is nothing but a torque splitter. So this is going to split the torque into two wheels. It may be at the front end or it may be at the back, and here you are going to have the wheels. Okay, so here you are going to have the wheels. See here, just I am showing the wheels. So these are the back wheels of our IC engine. So this here you are going to have wheel 1, wheel 2, and actually the torque is available on this shaft, and this shaft is going to divide to the wheel 1 as well as wheel 2. The torque is splitted. That's why this is also called as the torque splitter, or this is also called an differential. Okay, so which gives a differential speed at wheel 1 as well as wheel 2. So this is all about. Let's try to mark what it actually this is called as. So actually we are going to have different speeds at different points. So here I'm going to write down the speed of the vehicle is nw. So w is nothing but wheel, n is nothing but the speed of the vehicle, and here to convert this torque as per the required torque, we require a torque splitter. So therefore the number of gear ratio at the wheels is I naught. The number of gear ratio at the transmitter is Ig, and here you are going to have efficiency. Okay, so this is nothing but efficiency of the engine from, so efficiency of the engine, we are from engine to the wheel, so which is called as eta t. and you are going to have the torque generated by the engine, which is called as a TP. So TP is called as the torque generated by the engine, and eta T is called as the efficiency from the engine to the wheel, and here this is called as the gear ratio. So Ig is called as the gear ratio of the transmitter, and I naught is called as the gear ratio of the final drive. So let's try to define each individual turn. Eta T is called as the efficiency of the drive. So this is nothing but IC engine efficiency of the drive line from where to where. So the efficiency is from engine to wheel. And next term, IG. What is IG? IG is nothing but the gear ratio of the transmission, where I naught we are going to call the gear ratio of the final drive, which is nothing but the gear ratio of the at the final drive or at the wheels. So gear ratio at the final drive or at the wheels. So it requires some gears to convert from transmission to the wheels. It's called I naught, and where TP is nothing but a torque output. So this is nothing but the torque produced from engine. So these terms you should keep it in the brain while we do the derivation. Now let's try to understand how to write down all this formula. Let's try to write down. So I need to find out what is the torque at the wheels. So what is the torque developed at the wheels? Or it's nothing but we are going to write down it as torque developed at the wheels is equal to, which is nothing but this is a product of the gear ratio of the transmission multiplied with the gear ratio of the final wheel multiplied with the efficiency of the drive line from engine to the wheel multiplied with the torque of the power plant. It's nothing but torque produced from the engine. So this is how we are related all these concepts one by one. Okay, so this is how we calculated what is the torque developed at the wheel. So this is nothing but the torque developed at the wheels. So the torque developed at the wheel is an product of Ig, the product of Ig, product of I naught, and the efficiency of the turbine as well as the torque produced by the engine. So the product of all these four terms will give you the torque produced at the wheels. Okay, so this is the first derivation what we require, or first expression of torque developed at the wheels. Next one, we need to find out the tractive force. Okay, so tractive force, this is very very important, or generally we call this as a tractive effort, which is represented as a FD. So this is nothing but the tractive effort or tractive force. This is the force required by the IC engine to propel it from inertia. It has some inertia, where this inertia is called initial weight. So any vehicle will have some initial weight or weight of the vehicle. So the force required by the engine to propel the electric vehicle to forward direction. What is the force required by the engine to propel to the forward direction is called tractive effort. So tractive effort. So we have the formula for torque and force is force into radius. So this radius I'm going to call it as a d. But now want to find out the tractive force, which is nothing but the tractive force or tractive effort. So I want force, which is nothing but torque divided by RD. The RD is the radius of the wheel or the radius of the drive line. So where RD is called the radius of the wheel, D is called at radius of drive wheel. Okay, so this is there. What is this torque? This is nothing but torque produced at the wheel. So already what is the formula of torque produced at the wheel, which is nothing but Ig I naught eta T into TP divided by RD. Then you are going to find out the tractive effort produced at the wheel. So what is the tractive effort produced at the wheel or the wheel drive is nothing but torque by radius. Okay, so this is how to find out the maximum force or the tractive effort or the force developed at the wheels of an IC engine. So if you want the how this tractive force is developed is, let's try to have, this is our IC engine wheel. So see here, so here we are going to have, so this is nothing but we have the IC engine wheel, and you are going to have, so I'm not much expert in drawing the circles or diagrammatically, just for your understanding. So you have the wheels are there on the road, and you can see here, so this wheel has to be moved, then it requires some sort of force. So this force, what it requires to move on the road is called as a tractive force. And if you consider the radius, okay, so from this point to this point I'm taking, to this point to this point, which is nothing but the radius is RD. So the radius of the wheel from center to the outer reference is nothing but RD. So this is nothing but the radius of the wheel, and this is the force required by the vehicle to propel on an road, where this force is called as a tractive force. And this is the velocity required by the electric vehicle in meters per second. That's why if you call the, what is the vehicle speed, we call it as the speed is nothing but how many kilometers traveled per hour. So it is it may travel with 40 kilometers per hour, where this is called velocity. So that's how we say how it travels on the road. Now we require the formula for what is the velocity, what is the speed of the wheel drive. So next what we require is the speed of the drive wheel. What is the speed developed by the drive wheel? So speed in which the wheel drive is rotating is nothing but given by the formula of the speed of the plant divided by Ig I naught. So when you come back here, so I require Nw. So this is nothing but the speed of the wheel. Speed of the wheel is equal to the speed of the power plant. So the speed of the power plant or the speed of the engine. So speed of the wheel is equal to speed of the power plant divided by Ig I naught. Okay, so Np is called as the speed of engine or speed of the power plant. So in general, engine is also called as power plant. That's why it is suffixed with P, where this is called as the speed of the drive wheel. And now we need to calculate what is the velocity exhibited by the wheel. So we are going to calculate the velocity at the wheels. What is the amount of velocity developed at the wheel? V is equal to, in terms of meters per second, we need to derive. So velocity can also be written as a, so how to write down the velocities? We can write down as r into, so generally we can be written as a r into omega. So where omega is nothing but angular velocity, so angular velocity is nothing but radius is r, omega you can write down it as 2 pi n divided by 60. So 2 ones are 2 30s. So the resultant you are going to get which is nothing but r multiplied with pi n divided by 30. So what is the radius of the wheel, or what is the radius of the or drive or the wheel is rd multiplied with pi into the speed. What is the speed at the wheel? N omega. This already we have. What is the speed at the drive wheel? Which is nothing but nw divided by 30. Okay, when you substitute, then we have been calculated the velocity which is developed or to propel the electric vehicle, which is nothing but in meters per second. If you substitute the value of what is the speed of the wheel, which is nothing but RD multiplied with pi by 30 into what is the speed developed by the wheel? The speed developed by the wheel is the speed of the plant divided by Ig into I naught is the velocity at the wheel. You see here, now we have been derived what is the velocity developed by the wheel is Rd pi by 30 into Np divided by Ig I naught. And what is the speed of the wheel? It's nothing but the speed of the wheel is equal to the speed of the engine divided by Ig, I naught is the second derivation. And coming to the third, what we require is the tractive force developed by the wheel. The tractive force, which is nothing but torque divided by the radius of the wheel. The torque is Ig, I naught into efficiency of the plant from the engine to the wheel and the torque of the power plant. So this is nothing but the torque developed at the power plant. Next, we want to calculate what is the torque at the wheel, or what amount of torque is developed at the wheel. The torque at the wheel is equal to, so this is called as the gear ratio of the transmitter, and I naught is the gear ratio of the final drive, and the efficiency of the plant is called torque of the power plant. Just to multiply all this product, we are going to have. So successfully we have been analyzed what are the different vehicle power source. Power source means is nothing but vehicle engine. So engine characteristics with respect to the torque at the wheel, the tractive force at the wheel, the speed of the wheel, as well as the velocity at the wheel, we have been successfully calculated. All these are called as vehicle power source characteristics. So we have to draw this power, speed and torque characteristics. That these characteristics we will discuss later. So all these four parameters are called as vehicle power source characteristics of an IC engine. In the upcoming class, we will try to continue how these parameters of an IC engine are compared with our electric vehicle characteristics. Almost all the characteristics will be same. Hope you are able to understand the content. So we are going to map the characteristics, power, speed, torque characteristics of an IC engine with an electric vehicle. If you feel the content is useful, please like, share with your friends, and give your valuable comments or the doubts. So thank you for supporting us to develop a content for you. Thank you. Yours faithfully, Ram.